Hello there, this is a geometry video. It is chapter 10, section 8, and today we'll be discussing equations of circles. We've been doing so much with circles in this chapter, but we finally get to do equations of circles. And so, to get started, we have some definition, I guess, for you. The equation of a circle is defined as basically the set of all points that are equidistant from the center. So since all points on a circle, and we already know that, the radius of a circle, all the radii are the same, hence this distance anywhere in the circle is always the same. But we're going to get a little more mathematical right now on how that comes to play out into the equation. So it says, since all points on the circle are equidistant from the center, you can find the equation of the circle by using the distance formula, which you're well familiar with. Leg squared plus leg squared equals r squared. It's basically the Pythagorean theorem. And so if you let a point on the circle represent xy, then you can use Pythagorean theorem, which would be leg squared equals hypotenuse squared. So you would get x squared plus y squared equals r squared. And now it says suppose the center is not at the origin, but at the point HK. So if you do that, all that's going to happen, like in this case down here, if the center is not at 0, 0, then you're going to have to move this direction. So let's say, for example, that H was 5, then that just means that you're going to end up with x minus 5. Because if you have x minus h, then you would get positive 5, which would be your center. So I'm not sure if that all completely makes sense to you right now, but here's the distance formula. And to get the leg of the circle, so if I could just, let's see if I can draw on my board here real quick, so you can kind of see what's happening. So let's suppose that I kind of create a right triangle here. I'm trying to figure out this distance. So if I use these 2 points, then to find this length, I have to take the x-coordinate of this point, which is x, and subtract the x-coordinate of this point, which is h, hence why it has x minus h. And for the y, same thing. I want to take the y-coordinate here, which is y, and subtract it from the y-coordinate of this point, which would be the same as k. So I would get y minus k squared. And basically, if you then try to get rid of the square root symbol here, you have to square both sides. So you get r squared equals this little guy. And technically, that is basically the equation of a circle in standard form. So here we have it. X minus h squared plus y minus k squared equals r squared. That is our formula for the equation of a circle. And in that formula, the center of the circle is always hk, and the radius of the circle is always r. But be careful with that, because notice that in here, the h is negative, the k is negative, but in the center it's not. They're both positive. So basically what that tells us is that when you're looking at the equation, the center will always be the opposite sign of these values. And then for the radius, be careful that this is r squared. So in order to get the radius, you have to take this value, square root it, and that will give you the radius. So we're going to use this information to get to our first example. So it says here, write the equation of each circle. You don't actually have to have a graph of the circle to be able to do this. As long as you know what the center is and the radius is, we're just going to plug it right in to our formula, which said that this is h, k, and then this is r equal to 7. So according to the formula, we're going to take x minus h, and h is 1, squared plus y minus k, but it's minus negative 8, which is going to actually become positive 8, and then r squared, so 7 squared, which is 49. And just like that, you're done with part A. In part B, you're going to have a very similar scenario happening. The only difference with part B is that they didn't actually tell us what the center and the radius was, but you can get that information from the graph. So if you look here, the center here is 0, 4. And the radius, you can use your finger to count, going from the center to one of the edges of the circle, you get 1, 2, 3. So the radius is 3. So now plugging it into our formula, we're going to get x minus 0, because again, this is going to be my h, and my k. So x minus 0 is just x squared. And then y minus k, or minus 4 squared, equals 3 squared, which is 9. So you get x squared plus y minus 4 quantity squared equals 9, and that's all you have to do. So now you will have to do it yourself number 1, and we will go on to our next example. We don't have any more theorems today. All of our, the theorem that we have was the formula, is the only theorem that we have. The rest is just all examples of how you can apply all that information. So, write the equation of the circle with center at negative 2, 4. That passes through negative 6, 7. So, to do this, we're going to write down that we have our center. So what's happening here is that I want to see if I can draw this little guy for you. You have a circle. Well, let's, you have a circle of sorts, and what they're telling you is the center, and they're telling you that the circle passes through the point negative 6, 7. So let's imagine that over here somewhere is negative 6, 7, and the circle is passing through it. That's kind of what's happening. So we already have part of the information that we need to do our problem, which is the center is negative 2, 4. The other piece of information we have to have is the radius. And we don't have the radius because they didn't tell us what it was, at least not explicitly. So what we do know is that the radius has to go from the center to any point on the circle. And since it passes through negative 6, 7, that means that if I calculate the distance between here and here, that's equivalent to the radius. And so to do that, we're going to use the distance formula. So the distance formula is going to equal the square root, if you remember, of x2. So I'm going to go ahead and start with this point. So we're going to go negative 6 minus x1, which is negative 2, minus negative is positive. And then y is 7 minus 4 squared. So negative 6 plus 2 here is going to be negative 4. And when you square negative 4, you get positive 16. 7 minus 4 is 3, and then 3 squared is 9. So you end up with the square root of 25, and the square root of 25 is just 5. So now I know that my radius equals 5. Now I have all the information that I need to be able to write my equation of my circle. X minus h, but in this case h is negative 2, so x minus negative 2 is positive 2. Y minus k equals radius squared, so 5 squared, 25. And there is my solution. Notice again how I mentioned earlier that if this is a negative, it'll be positive here. If it's a positive here, it'll be negative. Those are always opposites. So just keep that in mind. We're still being consistent with that. So now you can do it yourself number 2. And then we will move on to our next example, 3. All right. So in example 3, it says the equation of a circle is x squared plus y squared minus 8x plus 2y equals negative 8. State the coordinates of the center and the measure of the radius, and then they want us to graph the equation. So this is where things start getting a little bit crazy, because this is going to require that you recall some Algebra 1, I know that's been a while, and it requires that you know how to complete the square. So I don't want you to panic if you don't remember how to do this. But if you don't remember how to do this, you'll probably want to watch this part a couple of times, rewind and then watch again. But there is a process to how you complete the square, and so we're going to do that first. And so the problem with this is that we don't have a perfect square, like we don't have x minus 5 squared. It's x squared and then minus 8x. So what we're going to do is we're going to complete the square first. And so the first thing I do is I write out the problem, keeping the x's together. So I want to take the x squared and the negative 8x, and then we're going to leave a blank because it's called complete the square, so that something is incomplete right now. So this is the part that's incomplete, and we're going to complete it later. And then we're going to go to the y's and keep those together. So we're going to have y squared plus 2y, and then a blank because we're going to complete that as well, and then it equals negative 8. So The process for completing the square is once you have it in this form, you have these three elements, which is kind of like a quadratic. If you remember the ax squared plus bx plus c, this is kind of like a quadratic with three parts. So you have two quadratics going on at the same time. So let's deal with one at a time first. And in these first three, the middle term is negative 8x. So you always take the middle term, divide that by 2, which gives you negative 4, and then square the result. That is how you complete the square. So you take the middle term, divide by 2, which gives you negative 4, and then square that, and it gives you 16. So 16 is the number that we're going to put in my blank. But whatever you add to one side, you have to add to the other. So I'm going to add 16 over here as well to the negative 8. Then we're going to do the exact same thing again for this second quadratic. So we're going to take the middle term, divide that by 2, and then square that result, which is still 1. So 1 squared is still 1. So we're going to add 1 and then add 1 here. This is how you complete the square. So again, if you didn't understand that part, you might want to go back and watch it again. You always take the middle term, divide by 2, square the result. So now I've completed the squares for both of them, and now I get to write them in factor form. If you were to actually factor out x squared minus 8x plus 16, you would get x minus 4 squared. So basically, the minus 4 comes from the minus 4 in here before you squared it, which tells us that for the second quadratic, it's supposed to be y plus 1 because this is a positive 1 before I squared it. So that's how that works. Okay? And then as far as the radius, we're going to have all these numbers and add them up. 16 minus 8 is 8, and 8 plus 1 is 9. So this is actually going to be your equation, but what they asked for was to state the coordinates of the center. So that means that my center will be positive 4, negative 1, and my radius is going to be the square root of 9, which is 3. So we've got that information already, but now we have to actually graph this circle, and that's where things will get a little interesting here, at least for me. I'm going to try to, maybe we'll go by 2s. I don't have that big of a graph here, so let's see if I can do this without too much issue. So if we go 2, 4, or this is 1, 2, 3, 4, 5, 6, 7, that might work. So we're going to go to 4, negative 1, so I'm going to go maybe right here. Trying to make sure that my circle will fit on my grid here. So we want to plot our center first. And so our center is 4, negative 1, so that's 1, 2, 3, 4, negative 1 will be right here. And then my radius is 3. So to graph, it's actually very simple because we know that the radius will be 3 in all directions. So the easiest thing to do is to go 3 units this direction will be here. 3 units in the downward direction will be 1, 2, 3 will be here. 3 units in this direction will be 1, 2, 3 here. And 3 units in the upper direction will be 1, 2, 3 here. So that's basically where your circle should be. And then you can use a compass if you have one to help you graph the little guy. Is that how it goes, or does it go the other way? Sorry, I'm trying to mess with my little compass here so that I can graph this for you. Alrighty, so what I'm going to do is I am going to maybe move this guy in a little bit, right about there. And then we're going to graph the circle. Kind of like that. And there you go. So that's basically what it's supposed to look like. Now the reason why it's not perfectly lining up is because my grid is not exactly a square, and my compass is going to always make it an exact circle, but you can see that this is a little bit longer than it is wider, and that's why it's happening. But that's basically in a nutshell what you're going to be doing as far as doing yourself. Number 3, there's a part A and a part B. So let me, there is 3a, x squared plus y squared minus 4 equals 0 up here. And then you will do part B, which is x squared plus y squared plus 8x minus 4. So this one you have to complete the square on both of them actually. And so then we will go on to our example 4. And example 4 is going to be a little bit tricky as well, in the sense that the grid is not an exact circle, an exact square, but I will try my best to at least kind of show you, model for you what you're supposed to do, and hopefully on your graph paper it'll work out better because it'll be an actual perfect square. But it says 3 tornado sirens are placed strategically on a circle around a town so they can be heard by all. Write the equation of the circle on which they are placed if the coordinates of the sirens are A, B, and C. So the first thing you want to do is basically get a triangle going with these 3 points. So we're going to go from all the way to -8. So here's a 1, 2, 3, 4, 5, 6, 7, 8. So we would go right about here and put our y-axis in, like so. And then as far as the x, we've got 3, 7, and negative. So I'm looking at the y value to see how far up I have to go to see how low the x-axis should be. My highest y value is 7, so 3, 5, 7. So maybe if we go right about here, we'll be okay. I hope that made sense how I figured that out. I need to have enough space for my y variable, so that's kind of depends on where the x-axis goes. So anyway, so now we're going to plot our points that we have. And so we have -8, 3, so 1, 2, 3, 4, 5, 6, 7, 8, and 3, 1, 2, 3 is up here. Then we have -4, 7, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. And then we have -4, -1, which is down here. So we get this nice little triangle guy going. Just like so. Alrighty, and so now what we have to do is to construct the perpendicular bisectors of at least 2 sides so we can get the center. So basically we're trying to get a circumscribed circle. We learned back in a few sections ago, or chapters ago, that the perpendicular bisectors will all cross in the same point, and that point will be the center of the circumscribed circle. So that's what we're trying to do. The easiest thing right now for us as far as constructing the perpendicular bisector is to recognize that this segment is perfectly vertical. So we actually know that if we count, this is 1, 2, 3, 4, 5, 6, 7, 8. The bisector would cut this into 2 equal parts of 4. So 1, 2, 3, 4 would be right here. And then it would also be perpendicular to this. So instead of being vertical, it would be horizontal. So I can tell you right now without having to construct that this perpendicular bisector is right there. Okay, so now what we want to do is find the perpendicular bisector of any one of the other 2 sides. And so that you remember how to do that, I'm going to show you. And again, it might not be perfect because I'm not working with a perfect grid here, but you at least understand how the process works. So what you want to do, remember, when you construct the perpendicular bisector is to put the needle point of your compass on one side of the segment and make sure that it's open more than half, and then you make an arc. There we go, on top and bottom. Then you go to the other side of that same segment and do the exact same thing. Make another arc, top and bottom, and what's supposed to happen is that they're supposed to cross. And where they cross is basically where you draw your perpendicular bisector right through. So we're going to go through this point here and this point here, and we are going to construct the perpendicular bisector like so, like that, okay? And then where the 2 perpendicular bisectors intersect, that is your center. Now, like I mentioned before, I knew that that was going to be a problem here because my grid is not exact, but I can tell that it's pretty close to where it should have crossed, which is right here. Now again, you'll have more luck because your grids won't be skewed like mine, but so we can tell that it's supposed to cross here, and if had I had a better graph, that's what would have happened. So once you get two of the perpendicular bisectors to cross, then that is your center. So we're going to pretend right now that we had a nice little graph, and that the center of this little guy is going to be -4 is the x-coordinate, and then the y-coordinate would be +3. So for this example, the two perpendicular bisectors intersected at -4, 3. And then what would happen at that point is that you could draw your circle circumscribed on this thing. And again, that'd be 1, 2. The radius here is going to be 4. So 1, 2, 3, 4. This would be a radius. And you would draw your circle. It would look something like this. Now obviously it would be done a lot better with a compass, but there you go. So my radius would equal 4. And now I have all the information that I need to write the equation of the circle. So it's going to be x minus -4, and then y minus 3, and then equals radius squared, so 16, and this would be the equation of the circle that would work. Alrighty, so that's how you do example 4. And then I'm going to give you the do-it-yourself question coming right up. And then we'll go to our last example, which is this guy right here. And so this guy doesn't require us to actually draw any circles or come up with any equations of circles. This is more of an algebra thing. It says find the points of intersection between the circle x squared plus y squared equals 4 and y equals x. So I want you to know that what's happening here is that you have a circle, and you have a line like y equals x, and they want us to find out where the two intersect. But remember that it is possible for this line to be tangent, so you could have only one point of intersection, you could have 2 points of intersection, or if they never intersect, you could have no points of intersection. But right now, we're going to figure out what the case may be, depending on how many answers we get, right? So you could graph it if you wanted to. X squared plus y squared equals 4 would be really easy to graph. It would be at the center, 0, 0. Your radius would be 2, so you would go 1, 2, 1, 2, 1, 2, 1, 2, and you have a circle that pretty much looks like that. And if you remember what y equals x looks like, that's like a linear equation, y equals mx plus b. The slope would be 1 to 1. The y-intercept would be 0, so you would be here up 1 over 1, down 1 over 1, and you would just get a line like that. So just on a quick sketch like that, you can tell that in this case, you are going to have 2 points of intersection, and the question is, where are they? But we can use algebra to figure this out fairly easily. We can take our equation, and since we know that y equals x, we can replace the y variable with x because y equals x. So we can say x squared plus x squared equals 4 because we're replacing the y with x. So now that means we have 2x squared. And if you divide both sides by 2, then you get x squared equals 2. And when you square root both sides, you get that x equals plus or minus root 2. So you have 2 places, positive root 2 and negative root 2, where the graphs intersect. But you also have to have the y-coordinates. It wants the point of intersection. So when x is positive root 2, they want to know what y is. And when x is negative root 2, they want to know what y is. But all you have to do to figure out the y-coordinate is to plug the x-coordinate back into this equation here. That would be the easiest. And since y equals x, it means that if x is root 2, so is y. And if x is negative root 2, so is y. So our 2 points of intersection are root 2, and negative root 2, negative root 2. So that is how you do example 5. And so now we will let you do-it-yourself number 5. And once you have completed this do-it-yourself question, you will have completed your notes for this lesson. And I will see you in class. And thank you for watching.